Today's lesson is going to be about the Master and Wizard level questions for the Rocking the Boat Concept Builder. I wanted to show you before we get started, right underneath where you would launch the Concept Builder, there are some links, and I want you to click the questions link because that actually takes you to all of the questions that are in the Concept Builder. So if you need some extra practice, you have access to all of the questions. And down below at the very bottom, if you click questions in PDF format, you can see you have a nice way to print all the questions out and practice them. Okay, so the next thing I'm going to show you, well, first I'll show you something fun. I just thought this was really cute. My dog is practicing social distancing, and he's having virtual play dates with Lady and the Tramp on the TV. So that is the fun picture for the day. Now we have a reminder of the apprentice level picture and question. We have here, when the first boat is at the highest point, the second boat is at the lowest point. We have no wave crest between the boats, and you would get some information telling you about the distance separating the two boats. I'll just call that D. And we determined that if a crest and a trough makes a whole wave, let me zoom in here a little bit. All right, so if a crest and a trough, if that's taking up the space for one whole wave, then D would be taking up the space for half of a wave. Well, in the Master and Wizard questions, we're going to take those boats and move them farther apart. So D will not be equal to half of a wave in the Master and Wizard level questions. So first of all, let's go over how to pick the right diagram. And we can compare the first two questions where in the first one, we have the first boat at the highest point and the second boat at the lowest point, and we're going to have one wave crest between them. So this guy is at the highest point. I'm going to make sure that there's going to be one wave crest and make sure that the second boat is at the lowest point. And in the second example, we're still going to have one wave crest between them. There's the one wave crest, except now the first boat is at the highest point and the second boat is also at the highest point. Okay, so highest, I'll use H for highest and highest. Okay, the next two example problems will be similar, only now we're going to have two wave crests between them. Same thing here, two wave crests. So in the first example with the two wave crests, the first boat's at the highest point and the second boat is at the lowest point. Here I'll circle my two wave crests. And okay, so I have this guy at the highest point and the other guy has to be at the lowest point. And the last example we're going to look at, again, we have the two wave crests with the first boat at the highest point and the second boat at the highest point. So we have the highest point and the highest point. Okay, so that's how you're going to choose the diagrams in the master and wizard level questions. And then, of course, you get the questions where you have to find the wavelength, the frequency, period, amplitude, and speed of the waves. Well, what I'd like to address here is how do you go about determining that wavelength? Because before, just to show you in the apprentice level, we knew that the distance between the boats would always be half a wave apart. But now you can see the boats are farther apart, so they're going to be more than half a wave apart. So here's how we're going to figure this out. In the paragraph that I'm looking at now, the horizontal distance between the boats is 12 meters. So I'll mark that onto my picture. We have the distance of 12 meters. And one little trick that I like to remember, oh, there's my little star. It doesn't want to keep my star. When you go from the top of one crest to the next crest, right, from the top of one crest to the next crest, that's a whole wave. So that's one wave. And so then we just have this itty bitty piece left over, which is exactly like what we were doing here in the apprentice level, right? Going from the top of one crest to the bottom of the trough. So that's what we have left. The top of one crest to the bottom of the trough. So that's half of a wave. So it looks like in 12 meters, we have 1.5 waves. So I can write it this way. 1.5 lambda is equal to 12. I could write it this way. 1.5 lambda is equal to 12, and then divide both sides by 1.5. My marker or my magic pen's not so magical. All right, and then finally, I like using fractions. So instead of saying 1.5 lambda, I could also say 3/2 lambda is fitting into 12 meters. And this is where I like to use that little reciprocal trick. So I'm going to multiply both sides by 2/3, and everything cancels out on this side, and I get lambda. 12 times 2 is 24. 24 divided by 3 is 8 meters. So one wavelength, which would actually be, right, this portion here, 1 lambda, is 8 meters. And that should make sense because if we're going from the two boats and we're getting 12 meters, right, going from the top of one crest to the top of the next crest should be smaller than that. So yes, our wavelength is 8 meters. Now let's take a look at the second picture. This one's a bit easier because when I go from the top of the first crest to the top of the very next crest, that's one wavelength, 1 lambda. And then look, I'm going from that crest to the next crest. That's another lambda. That's another lambda. And so in all, I have 2 waves, 2 lambda, fitting into the distance between these two boats. Right, they tell us the distance between the two boats now. It's 16 meters. So now I can say 2 waves fit into 16 meters, and I'm going to divide both sides by 2 and get 8 meters for my wavelength for that picture. In example 3, I'll go from the top of the first crest to the top of the next crest and call that one wave. And then I will go to the top of the next crest and call that another wave. Oh, and then look, I have that little bitty piece where I'm going from the top of one crest to the bottom of the trough. And we know that that's half of a wave. So in all, I have 2.5 waves now. 2.5 lambda fitting into, this question says the distance between the boats is 20 meters. Oops, I touched something, sorry. So 2.5 lambda fits into 20 meters. Right, from here to here is 20. You can write it 2.5 lambda is equal to 20 and divide both sides by 2.5. I like to put it in a fraction form. 2.5 waves would be 5/2 lambda, fits into 20 meters. Then I can use my reciprocal trick. 2/5, 2/5, everything cancels here, and I get wavelength. 20 times 2 is 40, 40 divided by 5, 8 meters. Okay, so again, a wavelength, 1 lambda, would be 8 meters. And then finally, the last one, the horizontal distance is 8 meters. So the distance between the boats, 18 meters. And now to see how many waves we have fitting into that space, well, going from this crest to this crest, that's one wave. And then from here to the next crest, that's another wave. And yeah, one more wave. Looks like we have 3 waves, 3 lambda, fitting into 18 meters. So I write 3 lambda fits into 18, divide both sides by 3, and in this case, lambda is going to be 6 meters. So that's the only thing that's really different about the master and wizard level trophy questions.